Good morning, children. In your previous class, we have studied about the second law of motion and also about the mathematical formulation of the second law of motion. You just recall those, children. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of a force. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of a force, and that is F equals to m into a, where m is the mass of the object and a is the acceleration. And also the first law of motion can be mathematically stated from the mathematical expression for the second law of motion, that is F equals to m into v minus u by t. Here m is the mass and v is the initial v is the final velocity, e is the initial velocity, and t is the time. Now today we will discuss the problem, children. First one, a constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. Now, if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? See, children, a constant force acts on an object. Here, mass is 5 kg and time is 2 seconds, and it increases the object's velocity from 3 meter per second to 7 meter per second. When a force acts, its velocity increases from 3 meter per second to 7 meter per second, and you have to find the magnitude of the applied force. And now if the force was applied for a duration of 5 seconds, here time is 5 seconds, and you have to find what would be the final velocity of the object. See, children, here given that u equals to initial velocity, u equals to 3 meter per second, and final velocity v equals to 7 meter per second, and t is 2 seconds, and mass is 5 kg. From equation 9.5, which we have discussed in our previous classes, that is F equals to k into m into v minus u by t. Here substitute the values in this relation, children. It gives F equals to here m is 5 kg. M is 5 kg. Here you can leave the k here, children, because it is a proportionality constant. You can write it as F equals to m into v minus u by t. Now substitute the values here. Here mass is 5 kg and v is 7 meter per second and u is 3 meter per second. Time is 2 seconds. To solve this, 7 minus 3, it is 4 meter per second. 4 into 5, it is 20 by 2. You will get here 10 Newton. Unit of force is Newton. Now, if the force is applied for a duration of 5 seconds, that is t equals to 5 seconds, then the final velocity can be calculated by rewriting the equation 9.5. See, children, you rewrite the equation here. That is v equals to u plus f into t by m. You will get here, children, v equals to u plus f into t by m. Make it as capital F. It is u plus f into t by m. Now on substituting the values of u, f, m and t, we get the final velocity here. Now substitute the values here, children. U and f, t and m here. You will get here v equals to 13 meter per second. Now from this equation you can write v equals to u plus f into t by m, and now substitute the values of u, f and m. That is u is 3 meter per second. Here f is 10 Newton, t is 5 seconds and mass. Mass is 5 kg. Now substituting the values, you will get here V equals to 13 meter per second. That is the final velocity is 13 meter per second. Second problem, children, which would require a greater force. Accelerating a 2 kg mass at 5 meter per second square or a 4 kg mass at 2 meter per second square. You have to find out here which would require a greater force. Now, from equation 9.4, children, that is F equals to M into A. We know that F equals to M into A, and here we have M1 equal to 2 kg and A1 equals to 5 meter per second square. That is you consider, children, the 2 kg mass, it is M1, and 5 meter per second square, it is A1, and A2 is 2 meter per second square and M2 is 4 kg. Now we have F1 equals to M1, A1 equals to M1 is 2 kg into 5 meter per second square. You will get here 10 Newton. F1 is 10 Newton and F2 equals to M2, A2 equals to, substitute the values here, M2 is 4 kg and A2 is 2 meter per second square equals to 8 Newton. And this implies, children, here see F1 is 10 Newton, F2 is 8 Newton. From this we can say that F1 is greater than F2. Thus, accelerating a 2 kg mass at 5 meter per second square would require a greater force. See, children, accelerating a 2 kg mass at 5 meter per second square, it would require a greater force. Next, third one. A motor car is moving with the velocity of 108 km per hour and takes 4 seconds to stop after the brakes are applied. Now calculate the force exerted by the brakes on the motor car if its mass along with the passengers is 1000 kg. See, children, here a motor car, it is moving with the velocity of 108 km per hour and it takes 4 seconds to stop after the brakes are applied. Now you have to calculate the force exerted by the brakes on the motor car if its mass along with the passengers. If the passengers are there in the motor car, then its mass is 1000 kg. Here the initial velocity of the motor car is U equals to 108 km per hour. Convert this into meter, children. Meter per second, that is 108 into 1000 meter divided by 60 into 60 seconds. Here by calculating you will get here U equals to 30 meter per second. And the final velocity of the motor car, here final velocity of the motor car, that is V equals to 0 meter per second. See, children, the final velocity of the motor car is 0 meter per second. The total mass of the motor car along with its passengers is 1000 kg and the time is to stop the motor car T equals to 4 seconds. And we have the magnitude of the force applied by the brakes as M, that is F equals to M V minus U by T. On substituting the values, we get here F equals to mass is 1000 kg into final velocity is 0 meter per second and U is 30 meter per second by 4 seconds. You will get here, children, minus 7500 kg meter per second square, or it is minus 7500 Newton. Understood, children? Here the negative sign tells us that the force exerted by the brakes is opposite to the direction of the motion of the motor car. See, children, by solving this you will get here F equals to minus 7500 kg meter per second square, or you can write it as minus 7500 Newton. Here, children, the negative sign, it tells us that the force exerted by the brakes is opposite to the direction of the motion of the motor car. Next, fourth one, children. A force of a 5 Newton gives a mass M1, an acceleration of 10 meter per second square, and a mass M2, an acceleration of 20 meter per second square. Now, what acceleration would it give if both the masses were tied together. See children, here a force of 5 Newton, it gives a mass m1, an acceleration of 10 meter per second square, and a mass m2, an acceleration of 20 meter per second square. You have to find here what acceleration would it give if both the masses were tied together. If both these masses are tied together, you have to find here what would be the acceleration. Now we have children F equals to ma. You know that F equals to m into a. From that we can write here m1 equals to f by a1. See, m equals to f by a. Therefore you can write here m1 equals to f by a1 and m2 equals to f by a2. Here a1 equals to 10 meter per second square and a2 equals to 20 meter per second square. Make it as meter per second square children, and f is 5 Newton. Thus m1 equals to 5 Newton by 10 meter per second square. Substitute the values here children. m1 equals to f is 5 Newton by a1 is 10 meter per second square. This equals to, you will get here 0.50 kg, 0.50 kg, and m2 equals to, so again substitute the values here children. F is 5 Newton and a2 is 20 meter per second square. By substituting the values a2 and f, you will get here 0.25 kg. Understood children? Here the force F is 5 Newton and m1 mass gives a mass m1 and acceleration a1 is 10 meter per second square, and mass m2 and acceleration a2 is 20 meter per second square. That values you have to substitute here. You will get m1 equals to 0.50 kg and m2 equals to 0.25 kg. And if the two masses were tied together, the total mass m would be, see children, if these two masses were tied together, means m equals to m1 plus m2, that is 0.50 kg plus 0.25 kg. You have to add both m1 and m2 here, then you will get the mass m, that equals to 0.75 kg. The acceleration A is produced in the combined mass by the 5 Newton force would be A equals to F by m. From F equals to m into A, you can write here A equals to F by m, that is equals to 5 Newton by, here m is 0.75 kg. 5 by 0.75, that is equals to 6.67 meter per second square. Next one children. The velocity time graph of a ball of mass 20 gram moving along a straight line on a long table is given in figure 9.9. And figure, how much force does the table exert on the ball to bring it to rest? See children, here the velocity time graph of a ball of mass 20 gram moving along a straight line on a long table is given here children. You have to find how much force does the table exert on the ball to bring it to rest here. See, the initial velocity of the ball is 20 centimeter per second. Observe the graph here children. The initial velocity of the ball is, make it as per second children. It is 20 centimeter per second. From the figure you can say here. And due to the friction force exerted by the table, the velocity of the ball decreases down to 0. See children, due to the friction exerted by the table, the velocity of the ball, it decreases down to 0 in 10 seconds. Thus, that is initial velocity equals to 20 centimeter per second and final velocity v is 0 centimeter per second and time is 10 seconds here. Now, since the velocity time graph is a straight line, see children, here the velocity time graph is a straight line, it is clear that the ball moves with a constant acceleration. The acceleration A is given by A equals to v minus u by t, that is v is 0 centimeter per second minus 20 centimeter per second, u is 20 centimeter per second by time is 10 seconds. You will get here minus 2 centimeter per second square, or it is minus 0.02 meter per second square. The force exerted on the ball. See children, the force exerted on the ball F is F equals to ma equals to, here m is 20. See children, mass is see children, here mass is 20 grams. Convert into kg, that is 20 by 1000 kg into acceleration is minus 0.02 meter per second square. Now you will get minus 0.0004 Newton. See children, by solving this you will get here minus 0.0004 Newton. The negative sign implies that the frictional force exerted by the table is opposite to the direction of the motion of the ball. See children, here the negative sign implies that the frictional force exerted by the table is opposite to the direction of the motion of the ball. See, you have to find here A, that is the acceleration v minus u by t. Here 0 centimeter per second minus 20 meter per second by 10 seconds. You will get here minus 20 by 10, that is minus 2 centimeter per second square, that you can convert into meter, minus 0.02 meter per second square. Now children, the force exerted on the ball F is F equals to m into A. Here mass is given as 20 grams, convert into kg, 20 by 1000 kg into acceleration is minus 0.02 meter per second square. Now 20 by 1000 will get here and into minus 0.02 meter per second square. 20 by 1000, that is 0.020 kg into minus 0.02 meter per second square. You will get here minus 0.0004 Newton. Here the negative sign implies that the frictional force exerted by the table is opposite to the direction of the motion of the ball. Understood children? See, now we discussed about the problems based on the first law and the second law of motion. In next class we will study about the third law of motion. You solve all these problems in your fair children. Thank you.